Hello and welcome back, and if you are new here, welcome, we are very glad to have you here. In previous video we have demonstrated how to adjust and resize signal horizontally to best fit display. We also explained what is time division functionality of the oscilloscope. Through an exercise, we learned how to calculate period and frequency of an unknown signal. In this video, we will go next step and demonstrate how to adjust and manipulate signal vertically. We will learn about voltage range selector and what is function of multiplier selector as well. So, let's get started. In one of the previous videos, we talked about important parameters of every signal, one of them being point-to-point voltage. It tells us the absolute value of the signal, which is a result of potential differences, of point of the signal with lowest potential, and point of the signal with highest potential. This point-to-point value is an absolute value, and it is not referenced to ground, or earth zero ground. In layman terms, if width of the signal is its period, then point-to-point voltage is signal's height. Now, in previous video we have introduced our display template and mesh, that divides entire display into grid of 12 by 8 squares. We have also learned how to define and adjust width value of one square. Now, we will do the same thing for the height of the square. To facilitate this, we will use two switches on our oscilloscope board marked SEN1 and SEN2. When displaying a signal, both of these switches work in tandem to scale up, or down, the height of the signal, to best fit the display. So, let's set up our oscilloscope board, and set SEN1 switch to far left position, to 1 volt, and SEN2 switch to far right position, marked X1. Role of SEN1 switch is to set voltage range for display of input signal. It has 3 positions, 1 volt, 0.1 volt, and 10 millivolts. The purpose of this selector is not to predict point-to-point value of input signal, and set some internal mechanism accordingly. The purpose of this selector is to define and set height value of one square on the display mesh. So, when SEN1 switch is in position 1 volt, and SEN2 switch is in position X1, this means that height of one square equal 1 volt. You will also notice that bottom left icon on the display shows current value of SEN1 selector, in our case 1 volt. If we introduce a signal with point-to-point value of 1 volt, you guessed correctly, it will fit in 1 square by height. However, if we have previously centered our signal line to exact middle of the screen, our signal will most likely, in absence of any DC offset, be centered on the display as well, so it will occupy 1/2 of upper square, and 1/2 of lower square, in regard to centerline on the display. You will also notice that top right icon on display also shows point-to-point value of our signal, in this case 1 volt. From videos on how to center signal display, both horizontally and vertically, we can now manipulate our display, by selecting left-hand arrow pointer on the screen, and horizontal slider from top of the screen, to adjust and move signal display, so that our signal fits exactly 1 square. If time divider parameter is set also to 1 second, can you calculate what is period and frequency of our input signal? Leave the answer in comments section below this video. From one of our introductory videos, we know that oscilloscope can display signals with point-to-point value up to 40 volts. So, let's see what happens when we source and display signal with point-to-point value of 40 volts. We get this. A bunch of vertical lines, filling entire height of the screen. So, what has happened with our signal? Where are top and bottom lines of our 40 volts point-to-point signal? Our signal is there, alive and well, but with current settings for vertical scaling of oscilloscope's display, the entirety of the signal cannot fit on display. Top and bottom parts of the signal are very well above and below of what can be displayed. If we could see beyond confines of our display, our signal would look something like this. To address this problem, we will make use of our SEN2 selector to scale display, so that entirety of our 40 volts point-to-point signal can be displayed. Purpose of SEN2 selector is to multiply the value of selection of SEN1 switch. To put it simply, if SEN1 switch is set to position 1 volt, then setting SEN2 switch to position x1 means that height of 1 square of our display mesh is 1 volt. When we set switch SEN2 to position x2, now we are multiplying selection from switch SEN1 with factor 2. So, if SEN1 switch is in position 1 volt, and SEN2 switch is in position x2, that means that height of 1 square now equals 2 volts. The table on screen gives all values for all possible combinations of positions of SEN1 and SEN2 switches. So, to fix our problem with our 40 volts point-to-point signal display, we need to set SEN1 switch to 1 volt, and SEN2 switch to x5, so that height of 1 square of our display mesh equals 5 volts. Since we have, in total, 8 vertical squares, and given that 1 square, with these settings, equals 5 volts, that means that our entire display can now accommodate 40 volts point-to-point signal. Let's test what we have learned so far. Let's presume that we have 17 mV input signal, and we want to use entire grid to display our signal. Let's see how we can calculate values and positions of SEN1 and SEN2 switches in order to utilize our entire display to show our signal. In total, we have 8 squares available for our vertical display. First step is to divide 17 mV by 8. This gives us 2.125 mV per square to work with. Since there is no combination of SEN1 and SEN2 switches that gives us value of 2.125 mV, we will select next higher value. From table we can see that first available higher value is 10 mV. So, the combination of SEN1 switch set to 10 mV, and SEN2 switch set to x1, gives us the desired scale for signal display. This combination sets the value of height of 1 square to 10 mV, which means that our 17 mV signal will fit into 2 vertical squares, with some room to spare. What would happen if we choose the wrong settings? Previously, we saw that if we do not properly adjust scaling of display, our signal may leave boundaries of display, and not fit the screen, when we set our scaling parameters too low. Now, let's see what happens if we set our scaling too high. For same input signal of 17 mV, let's set SEN1 switch to 1 volt, and SEN2 switch to x5. Our signal is gone, and instead we have a flat line in the middle of the screen. Well, in truth, our signal is not gone, it is there, but high scaling makes it impossible to display small variations in amplitude of the signal, so our signal is flattened into a line. Lowering the scaling, by setting SEN1 switch to lower value, and adjusting scaling factor of SEN2 switch also to lower value fixes this problem. From this and previous video, we have learned how to manipulate scaling of the signal, both vertically and horizontally, in order to maximize available display space, and to display our signal as best as possible. In next video we will dive more deeply into built-in information display function of DSO 138 oscilloscope, so stay tuned. Please, before you leave, show your appreciation by liking this video, sharing it, leaving a comment, and consider subscribing. Thank you, and see you next time. Bye.